Okay, so we're doing chapter 9, problem 25. So we have a tennis ball of mass 0.06 kilograms and an initial speed of 25 meters per second. As we can see in this figure here, it strikes a wall at a 45-degree angle and rebounds off with the same speed at 45 degrees. And it says, what is the impulse, magnitude, and direction given to the ball? So we know that the impulse is given as the change in momentum. And from the symmetry of the problem, we see that the vertical momentum of the ball does not change, because initially we're moving upwards at the same speed as we are finally. So this is we only have to worry about the perpendicular component of the momentum. So the change of momentum here can be given as the velocity perpendicular final minus m times the velocity perpendicular initial. Okay, so let's just do that. So this becomes m times v naught sine of 45 degrees to get the initial or the final perpendicular velocity, and then we can subtract off negative v naught sine of 45 degrees because it's moving in the opposite direction in the x component initially. So this just becomes 2m v naught sine of 45 degrees. So we can find what that is. And this is 2 times 0.06 kilograms times 25 meters per second times the sine of 45 degrees. So if we plug all that in, we get a impulse of 2.1 kilogram meters per second. And which direction is this going to be in? Well, we know that initially we're having a to the right momentum, perpendicular component of the momentum, and finally we're going this way. So that means the impulse must be in the change in momentum, which is pointing to the left. So that's the direction. Magnitude and direction.